In this session, we study the first principle of mathematical induction with the help of one of the examples. So in this example, we want to prove that 2 plus 5 plus 8 plus and so on 3n minus 1 is equal to n in bracket 3n plus 1 divided by 2. So for this statement, we have the LHS and RHS. So whenever we want to solve such a type of the sum, first of all, we want to consider that mathematical statement as P of n. So we start with the solution. We want to consider the whole statement as P of n. That is a statement in the variable n. So 2 plus 5 plus 8 plus dot 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 plus 3 minus 1 is equal to n into 3n plus 1 divided by. To solve such a type of the sum, first of all try to understand the meaning of the statement. Now meaning of the statement is nothing but whenever we are adding 2, 5, 8 and such a sequence, so we are getting the sum is equal to n into in the bracket 3n plus 1 divided by 2. So what is our first step? In the first principle of mathematical induction, the step 1 is we want to check the statement is true for n is equal to 1. So for n is equal to 1 means for LHS we want to consider the first entry only. So for LHS my first entry is 2. Now for RHS what will be the our value? So whenever we are substituting n is equal to 1 into the RHS we are getting 1 into 3 into 1 plus 1 divided by 2. That is equal to 4 divided by 2, that is equal to 2. So LHS is equal to RHS for n is equal to 1, that is the statement is true for n is equal to 1, that is P of 1 is true. This is what our first step. Step 2. In step 2, we have to consider the statement is true for n is equal to k. So consider n is equal to k. The statement is true. Means just replace the n by k in the original statement. We are getting p of k. So p of k is equal to 2 plus 5 plus 8 plus and so on plus 3k minus 1 is equal to k into 3k plus 1 divided by 2. This is what we want to consider. In the step 3, we want to show that the p of k to show that p of k plus 1 is true by using the above statement, that is p of k. So what is actually we have to show that it is 2 plus 5 plus 8 plus and so on plus 3k minus 1 is our kth term. After that we are getting the k plus 1 term. So by replacing k by k plus 1 we are getting the kth term is equal to k plus 1 bracket 3k plus 1 plus 1 divided by, that is equal to k plus 1 bracket complete 3k plus 3 plus 1 divided by, that is equal to k plus 1 3k plus 4 divided by 2. This is what we require. That is, we want to show that the pk plus 1 is. So this is what our pk. Remember this pk to use the pk plus 1. So we start with the LHS of pk plus 1, that is equal to 2 plus 5 plus 8 plus dot 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 plus pk minus 1 plus 3 in bracket k plus 1 minus 1. So in the statement pk plus 1 we want to find out the some LHS of the pk value. So see, in this statement is the whole term is nothing but LHS of pk. So the value of this LHS of pk is equal to k into 3k plus 1 divided by 2, and the remaining term is nothing but 3k plus 3 minus 1. So this is equal to k 3k plus 1 divided by 2 plus 3k plus. Now we make the denominator same. We multiply numerator and denominator by. So what we are getting? We are getting 3k square. By multiplying k inside, we are getting 3k square plus k plus 6k plus 4 upon. So this is equal to 3k square plus 7k plus 4 divided by. After factorization this, we are getting the factor k plus 1 uk plus 4 divided by 2, and this is nothing but our required RHS. Therefore, statement is true for k plus 1, that is k plus 1 is true. So by first principle of mathematical induction, the given statement, that is P of n, is true for all n greater than or equal to 1.